In this video, we will talk about how to reflect a point over a line. So let's say that we would like to reflect the point 2, 4 over the line y equals negative 2x plus 1. So let's sketch this out really quick. So we have the point 2, 4, so that's 1, 2, 1, 2, 3, 4, right about here. And then the line y equals negative 2x plus 1. So first let's find the y-intercept. So when x is equal to 0, we can see that y is equal to 1. So we know it will cross right here at y equals 1. And the slope is negative 2, so that means go down 2 and to the right 1. So 1, 2 over 1, 1, 2 over 1, something like this. So our line looks something like this. So here's our line, and we want to reflect this point right here, 2, 4, over the line, and we want to see where does it land out here. So what are the coordinates that it lands out here at? So the way that we can do that is we can use this three-step process. First is we need to find the equation of the perpendicular line. So in other words, we need to find what is this equation of this line, because what we're ultimately going to do is reflect this point so that it lands somewhere else on this line right here, over here. So to find the perpendicular line, we just have to recognize that the slope of this current line is negative 2, and the slope of the perpendicular line will be the negative reciprocal of that. So if we want to write negative 2 over 1, that's the slope of this line. The slope of this line will be the negative reciprocal. So instead of a negative 2 over 1, we'll have a positive, and instead of 2 over 1, we flip the numerator and denominator. So we can write m perpendicular, so the slope of the perpendicular line is going to be 1 over 2. So it's going to have this format, y equals 1/2 x plus b. Now to figure out what b is, we just need to plug in values for x and y, an x and y coordinate that we know lies on the line. So that would be this coordinate right here, 2, 4. So let's plug in a 2 for x and a 4 for y, and we can solve for b. So we get 4 is equal to 1/2 times 2 plus b. So we get 4 is equal to 1/2 times 2 is just 1 plus b. To solve for b, we can subtract a 1 from each side, and we find that 3 is equal to b. So the equation of the perpendicular line will be y equals 1/2 x plus 3. So that's step 1. So I'm going to make a little room right here. Okay, so we found the equation of the perpendicular line. Step 2 is we need to find the intersection point between this line and the perpendicular line. So the way that we do that is we simply set these two equations equal to each other and solve for x. And once we know x, we can solve for y. So we'll say negative 2x plus 1, so this first line right here, is equal to this perpendicular line, so 1/2 x plus 3. So let's solve for x. So we can start by multiplying every value by 2, just to get rid of this 2 in the denominator right here. So we would get negative 4x plus 2 is equal to x plus 3 times 2 is 6. Okay, so to solve for x, if we wanted to, we could add a 4x to each side, and then we could subtract a 6 from each side. So over here, these x's cancel out. We're left with 2 minus 6, which is negative 4, is equal to, on this side, the 6's cancel out, and we're left with x plus 4x is 5x. To solve for x, we just need to divide both sides by 5, and we'll find that x is equal to negative 4/5. So once we've solved for x, we can plug it back into either one of these equations and figure out what y is. So let's plug it into this equation right here. So we'll say y is equal to negative 2 times negative 4/5 plus 1. So when we multiply these two together, we get a negative 2 times a negative 4, that's a positive 8. So we get y is equal to 8/5. And if we want, we can write 1 as 5/5, since that's the same as 1. So plus 5/5. So we get y is equal to 8 plus 5 is 13, so 13/5. So this point where these two lines intersect, right here, this intersection point, is going to be negative 4/5, comma 13/5. So I'll make a little room right here and write that. All right, the last step says use the midpoint formula to find the reflection location. So we have this original point right here, 2, 4. We found the perpendicular line along with the point of intersection right here. And remember, we're trying to find what is this final reflection location? What is this coordinate? What we need to recognize is that this intersection point right here is going to be the midpoint between our starting location and our ending reflection location. And remember, we know these coordinates. That's what we just found, -4/5, 13/5. So what we can do is use the midpoint formula, which is this. If we have two x and y coordinates, the midpoint between those coordinates is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So in this case, we already know the midpoint. That's these coordinates right here. So what we can say is the x value of the midpoint, which we already know, we can say -4/5 is equal to, if we want to call this coordinate x1, y1, then we can say 2 plus x2. So x2 is going to be whatever the x coordinate is right here, which we don't know yet, so we're solving for that, divided by 2. And then the y coordinate, remember we already know the y coordinate of the midpoint, that's 13/5. So we can say 13/5 is equal to y1, which we said let's let that be 4, plus y2. So y2 is going to be whatever the y coordinate is right here that we're trying to find, divided by 2. So we have two equations now, and we're just going to solve each one for x2 and y2. And once we do that, that's going to be our final answer. That's going to be our final reflection point. So let's do that. So we can start by cross multiplying each side. So we'll say -4 times 2, so -8 is equal to 5 times 2 is 10, plus 5 times x2 will just be 5x2. So to solve for x2, whatever this is, we can subtract a 10, and we get -18 is equal to 5 times x2. If we divide both sides by 5, we'll find that x2 is equal to -18 over 5. So there's our x coordinate. Now we just need to figure out what is our y coordinate. So we'll do the same process of cross multiplying it and setting them equal to each other. So 13 times 2, that's 26. I'll write that right here. 26 is equal to 5 times 4 is 20, plus 5 times y2. So plus 5y2. We're running out of space here, but that's okay. We'll subtract a 20 from each side, so we get 6 is equal to 5y2. To solve for y2, we can divide both sides by 5, and we get y2 is equal to 6 divided by 5, or 6/5. So we just figured out our x and our y location of our final reflection point. So our final answer is, I'll write it all the way up here, -18/5, comma 6/5. So that is our answer. So if we were to graph that, -18/5, that's almost -4, so something over here, like almost right here, and then 6/5 is just slightly greater than 1, so like right about here. So that's close to where we imagined our final point would be. So that's where the final point will land once we reflect it over this line.